for probability and statistics, you can't see. Hold on.
Our statistics
It's not bad. This is homework and notes and review all in one packet.
Oh,
yeah.
That's pretty niche.
So the very first thing we're going to need to do is to define a few things. The first thing we need to define is what is a set. A set, it says, is a well-defined collection of distinct objects. A set is just a list of stuff. If I were talking about flipping a coin, hold on, let me write where you can see it. If I were flipping a coin, what were my two outcomes? I could either have heads or I could have tails. Well, that's a set of all possible outcomes for flipping a coin. Each little outcome in here, that's an element of the set. It doesn't have to be anything specific. It could just be some random list of numbers, 2, 7, 9, 3, and 12. Like they have nothing in common, it's just a list of numbers. It is possible to have an empty set, so there's nothing inside of it. For example, the number of people in this classroom that have purple hair.
0.
Empty set, right? There's nobody in here that has purple hair. Number of elephants in the room. None, right? The universal set is all elements under consideration. So, for example, on your classwork today, your homework, you have a set of 10 cards numbered 1 through 10. The universal set would be all like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's all possibilities. Now, if I were to identify how many different elements are in the set, that's going to help me decide what the probability is. You know most of this. If I'm taking this row right here and I know somebody from this group of people is going to be checked out, what's the probability that's Aaron? Well, there's one Aaron, right, in this group of people out of how many? Yeah. It would be 1 out of 8. The probability that it would be Aaron is 1 out of 8. The probability that it is Marin is 1 out of 8. Okay, so you know most of this already. Let's just put it with a little bit more symbols than maybe you're used to seeing. Okay, so for example, set A is the set of prime numbers less than 10.
5.
So the prime numbers less than 10 are 2, 3, 5, 7. And this notation right here says the number in A is 4. That means 1, 2, 3, 4. There's 4 numbers in there. That's it. Set B is the set of even natural numbers less than 10. So what are my even natural numbers less than 10? 2, 4, 6, 8. Who do we appreciate? Okay. Wow. So there are 4 numbers in set B. Set C is the set of natural numbers less than 10 that are multiple of 4. So first of all, we give the set a name. We called it set C. And what does it mean to be a multiple? It's not what goes into 4, it's what? What's multiples of 4? So 4, then 8. Good. And we stop there because it has to be less than 10. What is it called if it goes into 4? Do you remember? It starts with an F. They're factors. Good. So the factors of 4, 1, 2, 4. Different. How many numbers are in this set? 2. And the universal set is all numbers less than 10. So if I were to list those, you have to put that little brace on there, which is enjoyable to watch you write. Some people really struggle, and every time I watch them write it, they always apologize. Like they'll write one and they'll say, I'm sorry, that's ugly. Always apologize. How many are in that one? 9. What's the notation? The number in the universal set is 9. The number of elements in the universal set is 9. Okay, now we're gonna talk about how we combine sets together. Yes.
So if it's less than 10, it's not including 10.
Correct.
So
Correct.
It would have to be like less than 11 to include 10, or
Yes.
10 and under.
Yes. So you'll see 2 different types of ways you can phrase this. Less than 10 stops at 9, right? If I wanted to include 10, I would either have to say less than 11, or less than or equal to 10. Yes. Okay, so how are we going to combine sets together? There's a couple more notation, a couple more vocabulary words. This symbol right here, that stands for subset. You can use the Venn diagrams to help you kind of illustrate what these are. In this one right here, do you see how the set C is completely inside of set B? Yeah. So C is a subset of B. It's kind of like if I have a box of marbles. There's a bunch of marbles rolling around on the bottom, and then I have a bag of marbles inside. Is the bag of marbles inside the box? Yeah. So it's like a subset of all of the marbles in there, but it's been like sectioned off to the side. So C is a subset of B. An example of that would be if, let's let B so an example, let's let set B be all of the students here at Westlake. What would a subset of that be? All the sophomores. Okay. Set C, sophomores. You're still going to the school. You're just a certain group in the school. This upside down U is the intersection. If you're looking at the diagram, I have set A, I have set B, and there's an overlap between them. This overlap right there, that's the intersection. So it has to happen in both. It's what do they have in common? So, if set A were all of the male students, of the high school, and set B were all of my students, what would the overlap be between those? Who's in both groups? The male students that are in my class.
I am.
So you're in both. Yes. So if I were looking at this picture right here, this little moon on the left, those are all the students that don't have me as a teacher. The right, these are all of my girl students. The overlap are all of my boy students, basically. Yeah. This right here stands for union. This one can happen in either. So if I have two different sets, so I have a set of a bunch of red marbles and I have a set of a bunch of green marbles and I throw them in the same box, they're all in one box now, right? They've been merged together. It's a union.
So merge the two kinds of two groups.
Yeah, we're going to merge two sets together. So, sorry. If we let set A be, let's do a number example right now. Let's let it be 2, 4, 6, 8, 10. So we'll have all of the even numbers less than or equal to 10. Let's let set B be all of the prime numbers less than 10. So what are my primes? 2, 3, 5, 7. One's considered not prime. Now if I wanted to merge those two groups together, if they were actual numbers like on a ping pong ball and I threw them into a box, what numbers would be in the box? 2. And now I don't have to list them twice. So 2, then 3, then 4, then 5, 6, 7, 8, 10. You don't have to list them twice. You don't have to list them in order. You just need to put them in there. The duplicates, if you again think of those as numbers on a ping pong ball inside of a box, the duplicates, the 2, that's the intersection. Are there any other duplicates? So I'm going to put this word right here, duplicate. It's another good way to describe intersection. So you need to think of some way to remember that the upside down U is an intersection and the U itself is a union. What do you think? How can you remember? The U is a union. U, right? I mean, it's the letter. So, and then you just have to remember that the upside down one is the other one. Okay, the last one is the complement. Based on the picture, can anybody describe what the complement is?
Outside?
Yeah, it's everything else. Now if I were to add the gray space out here with the set A, I get the whole box, right? So an A complement will always be the whole. For example, if I let set A be all students who attended Vista Heights, set A is all students who attended Vista Heights Middle School, what would set B have to be? Thank you. Now,
But there is no B.
Would it be
or sorry, what would set A complement be?
all students at Westlake?
No.
What's your
What's the opposite of the kids who attended,
all students attend?
who didn't attend? Because is it possible to have someone in this room that didn't go to either Vista or Frontier?
Yeah.
Yeah. So the opposite is not giving me another option. It's all students who did not. You're going to use like the exact same phrasing, but you add the word not in there. And then this little draw conclusion we're going to skip, but I'm going to ask you a different question. Is it possible to have two sets that don't overlap? But there's no intersection. Can you think of an example? So is it possible to have, if I were to draw a Venn diagram of that one, I'd have set A, set B.
Well, would you have to have two different variables then?
Sure. So if we have set A be black dogs, what could be a set that does not overlap black dogs?
White dogs. Right?
Or say it again. If we just if we had set A be black dogs and set B be felines, would there be any sort of overlap? Because a feline is a cat, right? Cats can't be dogs, so there's going to be zero overlap between them. If we had set A be black dogs and set B be dogs, what's that an example of? Set A would be a what compared to B? A subset, right? Yes. If we had set A be dogs and set B be black animals, could there be an overlap between those?
Yeah.
You have your dogs, you have your black animals, and oh, there exists black dogs. That's the overlap. Do you see the differences?
Would that be a union or
That would be, if I'm looking at the overlap, that would be an intersection. Yeah.
the union looks like
The union would be everything. It would be all black animals. So you'd have the panther, you would have your black horse, and then you'd have all of your dogs in your other kind of bubble. So if I were talking intersection, I'm talking this right here is only my black dogs.
I'm trying to see how to draw the Venn diagram. How it's
Oh, it would look like this.
Then why even have it like that? Why not just like
It would look like this.
purple?
Yeah. So you can see that they're separate. If we're using the dogs and the black animals, like these would be like the white dogs, the polka dot dogs, the brown dogs, the spray painted dogs, whatever, which don't do, by the way. And these would be the black dogs, and this would be everything that's not a dog but still black. Crow, panther, horse. Can't think of any other black animals. All right, now let's talk about probability for a minute. This symbol right here means the probability that A happens. In order to do that, we need to know how many people are in the group A. When we were talking about students being checked out of this row right here, we said how many people are named Aaron. 1, that goes on top, right? And we put it over how many people are in this row. 8 So we need to know the total. This S right here stands for sample space. We need to know the total. We need to know how many people or how many objects we're talking about. All right. I actually want to jump down to the your turn really quick. I think it's a little bit easier than the first example. So what's going to happen is you're going to be given a scenario. I would probably start by going off to the side and listing what objects are in the set. So numbers 1 through 30 are placed in a hat to determine the order which students will give a presentation. That means my universal set are the numbers 1 through 30. My sample space is 1 through 30. Event A is being one of the first 10 students to give their report. So what is going in here? Event A is being one of the first 10 students to give the report.
130.
I'm not doing probabilities right now. I'm just listing what is involved in set A. One of the first 10. Is that okay?
Wait, why is it one of the first 10?
Because that's what it says. Event A is being one of the first 10 students to give. Yeah, so it's going to define it right here. Event B is picking a multiple of 6. So what would be involved there?
6, 12, 18, 30.
That's it. Now looking right here, it looks like we need to know what A is, we need to know what the union is, we need to know what the intersection is, and we need to know what the complement is. So let's just go off to the side really quick and list all of those. A union B, what's involved in that set? So union, what do? We just throw them all in the same box and we see what's in the box, right? So 1, 2, 3, 4, 5, 6. You don't actually have to list all of these. You could just write 1 through 10 and know that there's 10 there. That's faster. Okay, so that's everything in A, right? Now let's look at B. Do we have to list 6 again? No, so then we just start with 12, 18, 24, 30, and that's it. Hey. Okay, give me 1 second. We haven't even really gotten to the answer yet. We're just defining what's in each different kind of set. Is that okay? Because all of this that we're doing off to the side is going to help us answer our probability questions. Is that okay? So let's look at the intersection really quick. This one, if I threw everything in the box, what's going to be the duplicates? What's the duplicate between B and A? 6. Just 6. So the union is throwing everything into a box. We don't care about duplicates. We list it once. It's all in there. The intersection is what are the duplicates. The last one is a complement. And the complement was everything else. So if A is 1 through 10, what would everything else be? 11 through what? 30. So you can do this all at the beginning, kind of look at it, or you can kind of do it as the problems arise. It doesn't matter. But this is going to make 3 through 6 very fast. On problem number 3, what's the probability that A happens? Well, how many are in A? 10. How many are there total? 10 out of 30. So 1/3. Done. That's it. Number 4, probability that the union happens. Well, how many numbers are in that union? I see 14 now. 14. So 14 out of what? 30, which is 7 out of 15. Make sure you reduce. What about the intersection? How many numbers are in that intersection? 1 out of 30. I had somebody earlier make a mistake and they said 6 out of 30. What's their error? Because they saw the 6, they said 6, right? You have to think how many units or how many elements are in the list, not what are they in the list, just how many are there. What about the complement? How many numbers are here? There's 20 here, yep. There's 10 that are not in there. 20 out of 30. Now compare these two. I've got 10 out of 30 and 20 out of 30. We said earlier earlier, between the set and its complement, you should have all of them, right?
Yep.
The 10 and the 20 make the 30? 2/3. That should happen every single time. So what I want you to do really quick is let's look at your packet. Let me borrow yours really quick. This packet, when we stapled them together, the front page was the notes. The very, very last page, it has a spinner on the back. That's your classwork for tonight. So you'll be ripping off from the back, you'll be doing notes on the front. So it's all one packet. Your classwork is the very last page in the packet. Will you try the first 14? Specifically maybe the first 8, but then if you have time, look at 9 through 14. And I'll be right with you.
Wait, are these things right up top? Are those already the sets?
Say it one more time.
There's like a bunch of things.
Yes.
That's the sets.
So when you look at this really quick, sorry.
Don't forget to stop your recording.
I'm going to let it keep going. So right here on the classwork, you have a description of what all of the different sets are. And then underneath that description, it lists them for you. So you don't really have to read that top one. You don't have to worry about it. It's not like the notes example where you have to define them yourself. You will have to do that eventually, but for this first example, it tells you what they are. You can ignore that first 4 lines. What? It's the very last page in your packet. So the variance like this. Yes. So standard deviation is that it? Yes. Do you guys want to still open or is it cold? No.
What is the first one?
Is D a subset?
Is D a subset of A? That means is everything that's in D also in A? Is D a smaller group of A? Let's look. So if I'm doing problem number 1, I want to know, is D a subset of A? So I'm looking at D. D has 2, 4, and 6, right?
Mm-hmm.
Is 2, 4, and 6 also in my A group?
Yes.
Yes. So is D a subset? Yes. Why?
So 1/3 of those are. We put 1/3.
No.
Oh.
Everything that's in D is in A2. Now A has some extra stuff that we don't care about. Everything that's in D is also in A. So now try 2. Huh?
Do we have these?
D's right here.
C-A-T-O.
Yeah, it's hard to see.
So it has to be the same numbers that are in it? It can't be like numbers in between?
Correct. It has to be, yeah, everything in D has to also be an A. So if D has anything extra, if D had, say, a 7 was also included in that set, then I would say no because their 7 is not on that list.
Okay.
Yeah. Every single one of them. So what did you guys get for 2? Is B a subset of A?
No.
Is everything in B also in A? 2 is, 4 is, 6 is, but 8 is not. And neither is 10. So because 8 and 10 are not in A, I'm going to say no, it's not a subset. My reason, 8 and 10 are not in A.
For number 3, do we count all the numbers that are included in both sides of the set?
Let's look. What does this symbol right here mean?
That's the one where it's.
That's the overlap,
Yeah,
right?
overlaps them.
So that's the duplicate.
Right, so there's 3 of them in there that are in both of them.
Okay, so that's what we count.
So is it 3 of 12?
No, we just, when it says this right here without the P in front, I just want to list what items are in the set.
Oh.
Yeah, so that's all we have to do. So the intersection, what are in A and in B? 2 is, 4, 6, and 12. So I'm not saying, I'm not giving like a 2 out of 9 or a 12 out of 4, whatever. That didn't make sense.
What do we give those?
When it has this down here, like number 9, probability of A union B. Yeah. So that's what I got for 3. This is the duplicates. This is the union. So what do I do with number 5? I just combine them. Throw them all in a box, list them. 1, 2, 3, 4, 5, 6, 8, 10, 12. So try number 6. And then what does this AC mean? A complement. That means everything that's not in A. So we look at A, we compare it with the universal set. What does the universal set have that A does not? 5, 7, 8, 9, 10, 11. What does the universal set have that A does not? A doesn't have 5, it does not have 7, or 8, 9, 10, 11. This is the union, right? Throw everything in a box, A and C. So just, and if you wanted to, I mean, they don't have to be in a specific order. So A is 1, 2, yep. So that's A, right? C is 1, we've already listed it. 3, we've already listed it. 5, 7, 9, 11. 12. Thank you. Yeah. Look at that, your first 8 should be done.
Okay, wait, so how do you know when to stop?
Right here it tells you, it will define what numbers you're looking at. So 1 through 12 is our sample space. Those are our only options. So that's where we stop. Yeah. Okay, jump back to the notes. Let's do this fruit example. We're not going to fill in every single box because I don't think it's necessary. I actually think it's kind of confusing. So your grocery basket contains 1 bag of each of the following items. We have a bag of oranges, green apples, green grapes, green broccoli, white cauliflower, orange carrots, and green spinach. When I first read this, I'm like, well, who cares what color they are? Well, you will in a second. You're getting ready to transfer your items from your cart to the conveyor belt for checkout. Event A, which is right here, is picking a bag containing a vegetable. So what vegetables do I have in my basket? We have broccoli, we have cauliflower, we have carrots.
How do you know that your vegetables are?
I know that I'm looking for vegetables because it says event A is picking a bag containing a vegetable.
Oh.
Yeah. So they have to define it for you, otherwise you can't do it. Event B, there's no place for it, but I'm just going to put it right here. What's event B?
Green vegetables.
Picking a bag containing a green food. So which ones are green?
The apple.
Grapes? Wait, do I have that one?
Spinach.
I think there's one more. Broccoli?
Broccoli's already on it.
I'm not listing. I'm listing my own, so nothing was on it.
Oh.
See where I'm at? There wasn't a spot to list the B, so we just put it on there. You'll be okay. Don't worry about erasing. You'll be fine. Okay, so S. S stands for the sample space. What's everything in your basket?
Wait, how do you know
For the interruption, may I get tried to the attendance office for checkout?
Yes, you can.
How do you
Have fun.
figure out what you're putting B in this category?
Because it says B is picking a bag containing a green food. So we looked through the list which ones are green.
Okay.
Yeah. So let's go back up to S. S is the sample space. It's all of the possible fruit or vegetable items in your cart. So S is orange, apple, grape, broccoli, cauliflower, carrot, spinach. This right here stands for the number of elements in the sample space, which is 7. So every time I do the probability on all of these, it's going to be out of 7, out of 7, out of 7. Because that's my total. So I'm not going to have to reduce anything. Yeah. So A, we've already listed them. The number in A is 4. Right? There's 4 items. The probability of A happening is how many items fit in A divided how many items fit in the sample space. This is the only time I'm going to fill in those boxes because you just need to know it. You don't have to write down the notation. So the probability of A happening is how many are in A, which is 4, divide how many are total, which is 7 total. So there'd be a 4 out of 7 chance I'm going to pick a vegetable first. Which I know, who cares, right? But whatever, let's continue.
Did you just write down all those possibilities?
Yeah, this is what this is, all the possibilities.
Those are each one thing that could happen.
Uh-huh, yeah. Okay, this one's the union. Union means what? Anything that's in either category, right? So broccoli. What else is in both, or what else?
Orange.
Okay, sorry, hold on. Let's list A first. I've got broccoli, cauliflower, carrot. So A is all of your vegetables, right? B is all of your green. So we add apples and grapes. So orange isn't in the category because it's not green and it's not a vegetable. Cauliflower is not in the category because it's not green. So that's my list of possibilities. If I want, or how many are there? 6. I lied, cauliflower is in there because it's a vegetable. Strike that. So orange is not in there because it's not in either of those two groups. So if I want to know the probability of picking one of the items from my union list, how many are there? 6 in the list. Out of how many total? 7. That's all. If I'm talking intersection, what's the overlap between those two? What are the duplicates? What is both green, spinach, and a vegetable? Broccoli and spinach. So, how many numbers are in that group? 2. If I wanted to find the probability of drawing something from the intersection, what would it be? 2 out of 7. And the last one is A complement. A complement is everything that's not in the group. And remember, if A is 4 out of 7, the complement has to be everything else, right? So I don't really care what they are. How many are not in the 4/7? 3 out of the 7. Because between the two, you have to have 7 out of 7. It's got to be the total. If you wanted to list them, what would they be? Orange. Grapes. Apples. Because what is set A? Set A is vegetables, so not vegetables would be orange, grapes, apples. Good. Okay, next page. Alright, this talks about the complement one more time. So if I have the probability of A, the probability of the complement, we add them together, we should get 100%. Sometimes, flip over to your classwork really quick, sometimes it's easier to figure out the complement and then subtract. For example, number 15. Not that any of these are really hard, but number 15. You roll a 6-sided dice. What's the probability that you don't roll a 2? Well, what's the probability of rolling the 2?
1 out of 10.
Rolling a 2 is 1 out of the 6 choices on a 6-sided dice. So not a 2 would be 5 out of 6. It's everything else. Sometimes it's easier to figure out what you don't want and subtract it. Number 17. We have this spinner. Each one of them have an equal amount of space, otherwise it's different. You roll the spinner. What's the probability of not spinning a 2? Well, the probability of spinning a 2 is 1 out of 12, right? So not a 2 would be, look at that, fast and done. Yeah. Try 18. Bag contains 2 red, 5 blue, 3 green. What's the probability of not choosing a red? Well, the probability of choosing a red is 2 out of 10. So not a red would be 8 out of 10. I don't know which one's easier. 5 plus 3 is 8. It doesn't really matter. That, though, can be simplified. So your final answer, 4/5. I always feel really bad for my kid when he walks home in the rain. Always happens. It always rains or snows right at this time when he's going to be getting out of school. It's okay. All right, go back to the notes. Okay, sometimes it's a little bit more complicated though. It's not just a 6-sided dice. Sometimes you have more than one option. We're going back to the notes. So we just looked at this complement chart, and now we're going to go down to this example. So one pile of cards contains the numbers 2 through 6 in red hearts. So I've got 2 through 6 here. Another pile of cards contains the numbers 4 through 8 in the black spades. Each pile of cards has been randomly shuffled. If one card from each pile is chosen at random, what is the probability that the sum will be less than 12? So this is what we're looking for. We want the sum to be less than 12. So the first thing you have to do is figure out what all the different sums are, right? It's kind of annoying. It doesn't take a super long time. So 2 plus 4 is 6. 4 plus 3 is 7. 4 plus 4 is 8. Then 9. Then 10. 2 and 5 make 7. 8 just goes up by 1. 8, 9, 10, 11, 12. 9, 10, 11, 12, 13. 10, 11. You can do one of two things. First of all, you may want to look how many boxes are there total. It's a 5x5 chart, right? So there's 25 total. And counting the numbers 1 through 19 is not that hard. You can either count the numbers that don't fit in this category and then subtract it from 25, or we can count the numbers that actually fit in that category. What would you like to do? Okay, so the numbers in the category. The sum will be less than 12. So 6, 7, 8, 9, 10 is less than 12. 7, 8, 9, 10, 11 is less than 12. Do I circle the 12? No, because that's not less than 12. So anything from that diagonal up. So how many do we see that are not circled? There were 6, right? 6 that are not circled. Which means how many are? 19, good. The probability of getting something less than 12 would be 19 out of 25. So, really quick, let's take a minute to talk about a standard deck of cards, because there's a couple problems on the assignment that talk about a standard deck of cards, and it is possible that there are people in here that aren't familiar with them. A standard deck of cards, yes, has 52 cards in it. The cards have two different colors, red and black. There's two different kinds of red cards. There are diamonds and there are hearts. It's coming. There are two different kinds of black cards, spades and clubs. This column right here, they're called suits. So a diamond is a suit, heart is a suit. Each, the diamonds, hearts, spades, and clubs, they each have 13 cards in them. 13 times 4 is how we get our 52. Starts with an ace. Oh, does not have a 1. 7, 8, 9, 10. Then you have a jack, queen, and a king. The jack, queen, and king are called your face cards because they have faces on them. So, probability of drawing a red card would be what? Probability of drawing a red card.
26.
Like 26 out of the 52, right? 1 out of 2. Half of them are red. Probability of drawing a club. A fourth of them, right? So there's 13. 1/4. 1/4 of the cards should be clubs. What's the probability of drawing an ace? How many aces are in the deck? 4 is the same as 1 out of 13. Yeah. What's the probability of not drawing an ace? 48 out of the 52. And then you would simplify. Yeah.
Wait, so it's the probability of choosing a red king 2 out of 52?
Uh-huh. Probability of drawing a red king, 2 out of 52. Which means what would the probability of not drawing a red king be?
Yeah,
50 out of the 52, yes. So that's one that's a lot easier to count. Okay, how many red kings do I have? 2. That means 50 of them are not red kings. Okay, moving on. We will jump down to the your turn right here, underneath the number 7. Okay, this is our last example, then you'll have the rest of the time to finish your classwork, which should be at least halfway done anyway. One bag of marbles contains 2 red, 1 yellow, 1 green, and 1 blue marble. Another bag contains 1 marble of each of the same 4 colors. So on anything like this, I'm going to draw a chart. You've got bag 1 up here, bag 2 over here. Bag 1 has 5 marbles in it. Bag 2 has 4 marbles in it. Sorry. In bag 1, we have 2 red marbles, a yellow, a green, a blue. And then going down vertical in bag 2, we have 1 of each. Red, yellow, green, blue. So unless you know what sort of combinations there are, it's really hard to find the probability. It doesn't take very long to write them all out, because how many are there total? There's 20 total, right? So looking at the row first, I've got a red. So what's going to happen is I'm taking 1 marble out of each bag, and I'm seeing what I get. So I could get a red and a red, a red and a red, a red and a yellow, a red and a green, or a red and a blue. Or yellow red, yellow red, yellow yellow, yellow green, yellow blue. This gave a lot of people biology flashbacks.
Yes.
Green green, green blue.
Going back to last 10 minutes.
Blue red, blue red, blue yellow, blue green, blue blue. $20 total options. So, number 8. See if you can do this all on your own. What's the probability of selecting 2 different colors? And you can decide, is it easier to count the different colors, or is it easier to count the same colors and then subtract? It doesn't matter as long as you do it right. Probability of selecting two different colors. What did you guys get? 3/4? So this is the way I would do it. I'd say those are the same. Ooh, those are the same. Those, and those. So 5 of them are the same, which means 15 of them are different. Reduced gets you 3/4, 75%. Any questions with that? If you counted up the ones I didn't circle, you'd get 15, right? Same thing. Number 19, what's the probability of not selecting a yellow marble? Well, all of these are yellow. All of these are yellow. How many yellows did I just cross off? 8. So there's 5, 6, 7, 8. So 8 out of 20 are yellow, which means how many are not yellow? 12. You can't count this guy twice. So be careful. 3/5. Good. 2 last questions. Can a subset of A contain elements in the complement of A? It's kind of hard to decide yes or no unless you draw a picture. So I have set A. I have a subset. It has to be inside A. Is that okay? And where would the complement be? Looks like an olive. So this is set A. This is the subset of A. It's inside of it. And the complement would be everything on the outside. Would there ever be an overlap between that little circle and the outside? No. Because that's inside of A. There's never going to be an overlap. Overlap. The subset will always be inside of A. It'll never be on the outside. Last one. For any set A, what does A intersect with the, what is that, empty set equal? If you have a question like this, sometimes it's good to just give yourself an example and see what happens. So A can be anything you want it to be. 1, 2, 3, 4. It can be any sort of random combination of numbers. The empty set has nothing in it. So what would be the intersection? What's the duplicates between those two?
Nothing.
So the duplicate is the empty set, right? There's no duplicates. What about the union? Yeah, the union's going to be set A, right? 1, 2, 3, 4.
Why?
Because you just throw them all in the same basket. Because that's the definition of union. Yeah. So union means put them together. Just list them all. Disregard duplicates. Just list them all. The intersection, what are the duplicates? There aren't any, so it's still the empty set. The union, let me give you one more example before I set you free. Maybe it will help distinguish between those two. If A was 1, 2, 3, 4, 5, you don't have to write this down, but if you want to watch, 6, 7, 8, 9, 10. So those were my two sets. I wrote this weird. That's okay. What would the intersection be? What are the duplicates between the two sets? There isn't any, right? So the intersection would be the empty set. There's no overlap. What would the union be? Throw them all in a line. What would it be? Everything, 1 through 10, right? Okay, that's all. What do you think? Miserable? Hard, easy? Your other factor? Quadratic formula? Graphing a parabola? Circles?
I like this.
Systems of equations? Drawing a marble out of a bag?
Yes.